Minnesota's observed quite a few changes in the different climatic variables. What we're seeing the most strongly is a decline in the frequency and the severity of extreme cold events in winter. This is really the number one change that we have observed so far. It really trumps all of the other changes in terms of magnitude and in terms of how broadly we see this. We see this pretty much everywhere. It's manifest as, places not getting as cold as they used to. Things that used to be pretty common in Minnesota, like going to -40 Fahrenheit in the northern part of the state during the winter time, or even we used to do -50 occasionally, and those are things that are just becoming much more exceptional, somewhat rare. And winter in general is warming the fastest of all of the seasons. It's warming since 1970. It's warming about 10 times faster than summer. So we all think that, with climate change, when you hear the term warming, you'd expect hotter conditions. But really what we've been seeing is it's the bottom is coming up. The coldest temperatures are getting warmer. So this is especially true in winter. It's especially true on the coldest days of winter. But we're also seeing this behavior in the coldest times of other seasons too. What we're not seeing very much of yet is that increase in the upper part of the temperature distribution, especially the hottest days of summer. Now, some of that is because we had some really hot times in the mid and late 1980s, but especially in the 1930s, which is when a lot of the statewide and local all-time high temperature records were set. And so it's going to take a pretty good feat to get beyond some of the values that were established during those very harsh years in the 1930s. But even in the period since 1970, in the last few decades, we're really not seeing any movement in the hottest days of the year, the hottest temperatures of the year. So primarily the warming that we've been seeing has been coming from the bottom. It's that we're losing those coldest temperatures. Other changes that we have seen that are notable are an increase in annual precipitation, and this has been especially true in the springtime, where we've been seeing more springtime rains, and it could just be that the spring rainy season or the summer rainy season is starting earlier. And this has also been most pronounced in the southern and some of the western parts of Minnesota. So that hasn't been even across the state. So for example, with temperature, we've seen the greatest increases in the annual temperatures and in the winter temperatures in northern Minnesota. But for precipitation, even though we have a statewide increase in annual precipitation, we're seeing the greatest increases in the southern part of the state. And one of the things that's related to this increase in annual rainfall is an increase in the frequency and the magnitude of the biggest rainfall events. These are usually, you think of the big thunderstorms, they will park in one place for hours at a time, and they're the storms that drop generally the heaviest rainfall of a given year at a given location. And what we're seeing is those storms are becoming somewhat more frequent, and they're also becoming larger. And in fact, in the last 15 years or so, Minnesota has seen a fairly dramatic increase in what we call the mega rainfall events, which is when you see 6 inches of rain covering 1,000 square miles or more. And just for people to get their minds around what that means, that's like covering 2 counties with 6 inches of rainfall, kind of 2 typical counties in Minnesota. And we only have about 12 of these events on record going back into the 1800s, and we're pretty confident that we haven't missed much. And of those 12 events, 5 of them have been since the year 2000. So we are seeing an increase in the magnitude and the frequency of our biggest rainfall events. And again, these are usually from gigantic thunderstorms that don't move very quickly. They just kind of park in place, and they can drop a lot of rainfall. And recent notable examples are the Duluth area flood of 2012, and also the state record-setting rainfall event from August of 2007 in southeastern Minnesota, when Hoka recorded over 15 inches of rain.
Mm-hmm.
In terms of other kind of exciting hazards that people tend to associate with a warming climate, heat waves have not really increased in severity or frequency, but that's using temperature as a baseline. When we look at the heat index values, which is more like what it feels like, there's still a somewhat mixed signal, although we do know that we're seeing increases in general in moisture in the air and in dew points. So at some point we will see more of these heat events just because there's more moisture in the air. But we're not seeing, from a temperature standpoint, we're not seeing anything outstanding yet in terms of temperatures. And drought is another tricky one because many of our systems are so sensitive to how much water they receive. And I think there might be a perception issue. If you have more days in between rainfall events, people tend to think it's drier. But when we look at the data, we haven't seen any trend in Minnesota. This is what we've observed. We have not observed any trend towards increased drought frequency or severity in Minnesota going back for the, over the long term, going back to 1895, or even in the recent 4 decades or so. So we're most confident that the extreme cold hazards are being affected by our changing climate, and they're really declining rapidly. So the extreme cold just isn't what it used to be. And I think everybody in Minnesota can sort of think of, oh yeah, I remember when it used to get really cold all the time, and now it's not doing that anymore. The next hazard that we probably have the most confidence about in terms of seeing changes in would be the extreme rainfall. We're seeing, it's not that every place is always getting more rainfall every year, but when we look at the big picture and put all the stations that we have together, we are seeing a long-term trend towards larger events and more frequent large events. And this is also supported by the 2014 National Climate Assessment. Snowfall is a little bit difficult because even though we have lost some of the character of our winter, we're still seeing increases in annual snowfall, and it's hard to say exactly what's happening at the level of individual snowstorms because we don't really have an excellent record of these. People have recorded snowfall in different ways over the years. But you might imagine that as winter continues to warm, you're going to get more precipitation events that used to be snowfall that will now be falling as either a mix of rain and snow or just as rain. And we've already seen some of that. We've been seeing a potential increase in wet days during the wintertime in parts of Minnesota. And then again, heat waves and drought, we're not seeing any real increase yet. In terms of changes within Minnesota, so how much is one part of the state changing versus another? It really depends on the kind of data that we have. And so the answer, if can we do it, is sort of variable. So again, for temperature, we can get, I wouldn't say really fine, but we do know that northern Minnesota is in general changing and warming much faster than southern Minnesota. We're all warming, but the rates are, in some cases, depending on the season, 2 and 3 times faster in northern Minnesota than in southern Minnesota. With precipitation, what we're really seeing in terms of a signal is the southern part of the state. And that means, from the Twin Cities south and in parts of the western part of the state. So the Pipestone Marshall area up into the Big Stone and Traverse County. Some of those areas have also been getting wetter relative to what had previously been average, and comparatively, the northern and northeastern parts of the state have not been getting as wet as fast, and in fact there has even been some sign of intermediate term drying in parts of northeastern Minnesota, and some of the forests are starting to show a little bit of this hydrothermal stress from years of sort of accumulating, not drought impacts, but just having a little bit of a water shortage. So, but as you get more specific on a spatial level, as you start looking at townships and cities, often There might be differences, but they're not statistically meaningful. We could not say, for example, with any confidence that storms in St. Cloud are getting worse, but storms in Minneapolis are not. We can't really do that. But we can make general statements about different parts of the state. Now, one of the values of climate modeling, especially the high-resolution modeling efforts, is that you can start to run the climate output through really high-resolution weather models, and if those are able to ingest information about topography and landscape and land cover type, you can start to answer questions about what might happen in the prairie pothole region, or where, in the boreal forest. But those efforts are still underway, and some of them haven't even begun. Yeah, all the things I just talked about, that's what we have observed. And as one example, and this is the folly of relying too much on what you've observed in terms of looking at what could happen. One is some of these trends that we have observed, if we had only used the past as a means for predicting the future, we never could have seen them coming 40, 50, 60 years ago. And so we just weren't on the way to where we are right now. So what the past data that we use tells us is where we've gotten up to this point with respect to climate. It doesn't necessarily tell us, here's where you're going. And the changes that we've had in Minnesota also are somewhat, well, they're similar to what we're seeing in some of our neighboring states and some of the southern Canadian provinces, but they're also very different from what we're seeing in other parts of the country and in other parts of the world. So this notion that heat waves have not increased here is somewhat unique. You can look out in parts of the western US where they are setting record summertime temperatures, where there have been more heat waves, where drought has been some of the worst on record in large parts of the United States. And we're seeing things like this around the world too. So if you just look at one particular region, and we're really just one region within the US, which is just one country in the world, that might not tell you the whole story. And we have to remember too, when we're dealing with complex ecosystems that have these huge interdependencies, the things that are happening here might not be the only thing we need to talk about, because if the climate is changing in a place where our migratory birds are going, that's going to have an effect on us right here also. So, and one of the things that determines Minnesota's general weather, and then to another extent our climate, is our proximity to various important geographical features. So the Gulf of Mexico sits basically south of Minnesota. And whenever the winds, especially in the summertime, but any season, when the winds are coming from the south out of the Gulf of Mexico, we get more moisture and we get wet. And you could look at any really wet year and you're going to see a predominantly or a more dominantly southerly flow bringing that air off of the Gulf of Mexico. Now, the wind only has to shift a little bit for us. If it comes out of the southwest instead of the south, then instead of blowing off the Gulf of Mexico, it's coming off of the Edwards Plateau and the desert regions in the southwest. And we get into a much drier pattern. And if you look at many of our very dry years, you will see not as much of that southerly wind coming from the due south, but instead southwesterly winds bringing in drier air from the desert and air that's then prone to becoming very hot. So in the last several decades, as we've gotten wetter, it could just be because we've gotten somewhat lucky. And there's no way of looking at that and saying, well, therefore we're going to have wet years all the way into the future. And because you can't just take the weather of the past and the climate of the past and project it into the future with any scientific confidence, we need to look at sophisticated models of the atmosphere to understand what's really likely to happen as we move into the future. This question of, well, what are these other kinds of climatic and weather anomalies? What do they have to do with climate change, and how are they related? It's a really good and also somewhat difficult question. One of the things we know about something like El Nino, which in Minnesota, when you get a big El Nino, you expect some things, and it behaves pretty well. You expect a warm winter. You expect an irregular snow season because you have these periods of really warm conditions. And if you think about that, that sounds a lot like what we've been seeing with our trends in the climate. Well, we know we don't have El Nino every year, and there's easy ways to detect an El Nino. And the question is then, when you have an El Nino and it's producing a really warm winter, how much of this is El Nino? How much of this is the climatic change? And really, how much of this is the regular variability that was already there that gave us some warm winters occasionally anyway? These are some of the difficult questions that future scientists and even some present scientists are going to continue to try and answer. But it tells us we can't just look at one season or 1 year and make a declarative statement about the climate, because we don't know if that 1 year is representing a trend, is representing an anomaly that was already going to happen, or is representing some kind of circulation pattern change. So in climatology, you really need lots of years of data. And the common baseline for climatology is 30 years. That's the 30-year normal period that the World Meteorological Organization recommends. And really anything longer than 30 years is enough where you can start to say, okay, here's at least a baseline for this particular variable that we're looking at. It's hard to go below 30 years for shorter records, simply because it's hard to get statistical significance out of that small of a number. So it's not that you need a 30-year trend to make a declarative statement about the climate, but you need years, and in many cases decades, before you really know you're going somewhere unusual. And one of the reasons we're so confident that what we're seeing is unusual is because we now have a decade over decade trend towards really rapid warming. And again, really rapid warming in the winter. And through all of that, we're still getting El Ninos, we're still getting La Niñas, some of which have made our winters really cold. We're still getting these polar vortex type episodes, which can, it's kind of the new fancy term for any time it gets really cold. And we're expected to continue to see those. But I think if you really pay attention, and this is true even from the winter of 2013 and 14 that was really severe, even in those extremely cold episodes, you're still not getting as cold as the extremely cold episodes of the past. So you can't necessarily make a climatic statement about a weather event or even a year or even 2 or 3 or 4 years. However, you can use those events or those combinations of years to get a better understanding of what the climate has been and is doing. The good thing about using observed data is you can be highly confident about what those data are telling you. And when you have enough data points that are showing pretty much the same, telling the same story, you can become very confident about that story. Because when you get into projections, you're not dealing with observed data at all, but instead you're dealing with projections of what you might observe. You do lose some of that confidence. However, some things just keep coming up. So one thing that is expected to continue is the loss of the severity of winter. And we are expecting no real plateau in this other than regular year-to-year, decade-to-decade variability, but a general long-term trend that will continue warming our winters. And as a result, losing even more of our cold weather benchmarks that had been so common. These kinds of things are really important because a lot of our ecosystems are in some way temperature dependent, and there are things that can live here because of the cold winter, and there are some things that cannot. And once you start losing that cold winter, you shift the balance of what can and cannot live here. Also, extreme rainfall is one where, aside from what we have observed and aside from what the science on observations tells us, the models are pretty confident that as we keep putting and increasing the storage of water vapor in the atmosphere, we're going to keep seeing bigger and heavier and more frequent rainfall events. So it doesn't mean that every year is going to be wetter. In fact, you could see some major events even in dry years. It's just that when you get a big event, it's going to have a higher chance of being bigger than the average big event of the past. And that's a trend that we're already observing and that is also expected to continue. In terms of things like heat waves and drought, we have some confidence. It's not quite as high, but and especially with heat waves. Heat waves appear that they are going to become more common by the time we get into the middle of the century. 2040, 2050, 2060, and that areas in Minnesota, according to the 2014 National Climate Assessment, might expect anywhere between 1 and 15 additional days per summer above 95 degrees. Now, that's pretty substantial because that would indicate a doubling, a tripling, or in some cases possibly a quadrupling of those current values. I mean, we generally don't see in most areas more than a single-digit amount of days above 95 degrees in Minnesota. So if we're going to be getting 10 or in some cases 15 more days above 95 degrees by mid-century, that's a big, big change. And that would be the kind of change that if we just looked at what's been happening, we wouldn't really be able to see it coming. We need these sophisticated models that understand the atmosphere to guide us and tell us what we should expect. And in terms of drought, it's very hard to model drought going forward, but what some of the models have been able to do is look at the number of dry days, days without precipitation, and then look at consecutive strings in the models of dry days. And when you do that, the same models that tell us we're going to keep getting wetter and that we're going to keep getting, and that we're going to begin getting more of these heat waves, they're also telling us we're going to see more consecutive dry days in the future. And that means more days between rainfall events, which could indeed be an indication of more drought. It's hard to know, and also because we're so sensitive to all that water, with our position relative to the Gulf of Mexico, a very subtle shift could either take us out of or put us into a drought regime. All we need is more winds coming out of the southwest to do that. So that's kind of the basic picture. We're going to be losing the severity of winter as we get into the future. We expect more extreme rainfall events, and they'll continue to be bigger, and an eventual increase in heat waves, and at least the potential for more drought than we have been observing, and at least more time between the big rainfall events, so more consecutive dry days. So it might not be drought, it might be more like micro drought, but we are seeing a tendency for that. If you want to look at just the next 10 years, you kind of have to take a blended approach because there isn't a lot of science saying, well, here's what to expect over the next 10 years. But we can take what we know about these hazards and make some reasonable assumptions. We have every reason to believe that extreme cold over the next 10 years is going to continue to do what it's been doing. We're going to keep losing it. So by the time we get into 2025, things that seem somewhat common right now might even be becoming a little bit rare. That's how quickly these winter extremes are changing. In terms of extreme rainfall, 10 years is not a big enough window for us to be really confident that we're going to, in that 10-year window, break an all-time state record or have a lot of stations that break their all-time rainfall records. However, it is enough time to say we at least expect somewhat of a continuation of what we've seen. So even if we're not breaking records left and right in the next 10 years, we're going to see some more of these big events, and they're probably going to rival some of the other big events in state history. The science just tells us that this is where we're going. In terms of heat waves and drought, although we can't say that in the next decade or so we're going to go beyond the historical bounds, because we haven't come anywhere near those historical bounds yet, there is reason to believe we should expect heat wave and drought anyway, because they're a normal part of Minnesota's climate. And depending on where you are, you could expect them every 5 to 10 years, depending on where you are in the state. So it's smart to expect more of these, even if they're not directly related to the changing climate. And that is yet. As I said, when we get deeper into the future, in the middle of the century, we are expecting more heat waves, and we are expecting more consecutive dry days and possibly drought. The basic snapshot of climate change in Minnesota is we have observed warming across the state. We've observed it in every season. It's fastest in the wintertime, and it's most dramatic on those coldest days of the year. Those coldest days of the year are getting warmer. We're seeing more precipitation, and we're especially seeing a tendency towards bigger and more frequent large rain events. And we have not yet seen much of an increase in drought or heat waves. When we look forward, we actually expect continue to see warming in winter. We're going to continue to see a loss of those extreme cold values, so that things that are really common now just won't be as we get into the years and decades ahead. We're going to continue to see increases in annual precipitation in general, but especially even when we go through dry periods, some of those really big precipitation events are going to continue to get bigger. We do expect higher frequency of heat waves as we get into the future. So even though we haven't seen those now, that's something we expect. And also drought does show some sign of increasing as we get into especially the middle part of the century, where we believe we're going to see more consecutive dry days or days without precipitation. So that's kind of the snapshot of what we've seen so far and where we're going based on quality controlled data and the latest science. When everybody started hearing about and thinking about climate change, the first question was, well, what do we do? It sounds really bad, it looks bad, the data suggests that things are bad. And so there's really two sort of basic approaches, and they're not mutually exclusive. One is mitigation. Let's try and slow it down or stop it. And the other is adaptation. Now, I know that most people here are going to be thinking about adaptation. And the difference is important. And one of the reasons that adaptation is so important is because it gets at what we can start doing right now to protect and defend ourselves and our systems from these changing climate conditions. And mitigation is really more about offsetting, slowing down, or even stopping some of the effects, some of the actual changes themselves. And that's much more of a long-term commitment. So all the sort of good choices that we make now that would help with mitigation, those are really going to pay dividends down the road. Whereas adaptation is really what you can do now to make your job or your, whatever you do, your livelihood, your home, your community better, safer, and more resilient.